All right, so we're going to pick off right where we left off. We got our graph of the function, and you can see it's got a horizontal asymptote there of 2.066, and that's actually the next question. What is the horizontal asymptote? Y equals 2.0666. It's the same as the c value from the function, whatever it was in the numerator. That's always going to be a horizontal asymptote. Will the population of Phoenix increase indefinitely? If not, what will be the maximum population? No. Uh, the maximum population will be 2.0666 million people. So I'm using that horizontal asymptote to determine what the maximum is going to be. Now for part D, according to the function, when will the population of Phoenix reach 1.8 million people? Well, I'm going to do two things here. One, we're going to look at our little handmade graph, see what our estimate is, and then we're going to plug it into GeoGebra and see what happens there. So I go back up to my graph. I want to know when it's going to be 1.8. And I take a look here, and I'm going to do this in blue. 1.8, so this is 1.25, 1.5, 1.75, so a little bit above right there. So I'm going to bring it over, and it looks like, well, oh, shoot, we already actually kind of figured it out. It looks like it's going to be about 50 years. So I could say down here, when does it look like it's going to reach a population of 1.8 million people? It will likely be in 50 years that the population reaches 1.8 million people. Now, if you take a look here, it's 50 years. If we look all the way back in the beginning of the question, it said it's modeling it after 1980 as year zero. So that means the year 50 plus 80 is 30, well, 130, so 2030. Now, in GeoGebra, when we do this, let me open up a tab here for GeoGebra. I just have to be careful when I'm typing in the function. So the function y equals 2.0666 divided by 1 plus 1.66, and I need the e. And if you take a look here, there's actually an e as an option for your graph. And we need the exponent now. Negative 0.048. And instead of t, we're just going to use x. And there is my graph. Did I put the right number of zeros in there? Yep. Let me make sure I typed it in correctly. Yep. Okay. So now one thing, when I'm looking at this graph here, I'm only looking at it in the first 17 years, right? I don't want to look at it in terms of 17 years. I want to look at it in terms of hundreds of years, because I needed to go all the way up to 500. So I'm going to use my graphics view. And I'm going to grab that x-axis, and oh, come on now. Grab that x-axis, and I'm going to squeeze it down. And you can see, as I squeeze it down, how it kind of levels off there. Okay, so now, all right, there's 500 in our screen, and we'll go ahead and expand this out a little bit here. And you can see with my logarithmic growth here, it matches pretty closely what I drew by hand, right? It's stretched a little bit different because I'm using a different scale on the computer, but it looks about the same. Now, one thing you can do, go back to the calculator, and we said there was a horizontal asymptote at y equals 2.0666. If I put that in real quick, you can see that that's what it looks like the graph is approaching. It's approaching that line, and it doesn't seem to really go over it. One of the questions was, will it ever go over it? And if you go out far enough, it never seems, even 2,000 years in the future, it's not over that. So now in 2,000 years to the future, is the population of Phoenix only going to be 2,000 people or 2 million people? No, it's going to be way different because we can't predict everything that happens, right? We could discover free energy and it just makes it super big, or we could discover, or like a bunch of people could get sick, right? And like, or maybe it gets uh, like radiated by the sun and you can't live there anymore. So there's all kinds of crazy things that could happen, right? But our logistical model does a pretty good job for a longer period of time than what the normal exponential growth model does. All right. So that is how you deal with a logistical growth model. And if you want to check your graph when you're doing one of these problems, throw it in GeoGebra. Just be very careful about plugging in the formula